Okay, welcome to the Chemical and Physical Changes Lab. This is going to be experiment number 1. Now, if you read this, you can see this is a kind of a simple chemical physical change. I'm in the lab, and even though you're watching this first, I've already done the other 6 experiments already, so this is the last one that I'm doing first. I'm not going to do this one, okay? I want you to do this one at home. You don't have to do it right now, but you have to do it, okay? This is like simple chemistry that you could do at home. Go get into the kitchen, get a pot, get a small pot. You don't need a big pot or even a small frying pan, and get it, put it on a table, and go in the freezer and get 3 ice cubes. 1, 2, 3, 3.0 ice cubes, and put the ice cubes in the frying pan. Think about a couple things. The ice cubes are solid H2O. When you put them in the frying pan, they do not flatten out and conform to the shape of the pan or the pot you put them in. They hold their shape. Solids have a definite shape, and you can't squish them. You know that. You couldn't squish them. You're not that strong. Solids are not squishable, so they have a definite shape and a definite volume. And I'll leave them in the frying pan. I'll leave them in the pot. Just watch them for a while. I'm going to keep talking. You, every once in a while, glance over there. You watch these ice cubes. What are they doing? If you're lucky, they're singing. They're singing you a song, because it's boring to watch ice cubes hang out. But they're not singing. They're melting. They're undergoing a phase change. Now, the ice cubes are at a temperature that's so cold that the molecules are moving so slow that their attraction to each other is stronger than the kinetic energy they have. They don't have a lot of kinetic energy. They don't move hardly at all. In fact, they move so little that practically go a little bit of humming, a little bit of moving, but they're stuck together. But as the air gets at them, the air temperature is going to get in there and shake them, shake them, shake them, until all of a sudden they go like this, humming. All of a sudden they start to break apart and they start to move, and they're still kind of sticky. They're sticky together. They're attracted together, but they're not stuck, and they turn into liquid water. Now the water is still pretty cold, not absorbing a lot of energy yet. It's enough to get through the phase change from a solid to a liquid. The temperature of the water is going to stay at 0 degrees, liquid, until all the ice is gone, right? All the energy now is going to melt the ice. And give it a couple minutes, and if you want, you can hurry it up, because, you know, it's kind of silly watching ice cubes melt, but they're going to melt. They're undergoing a phase change. Now, once all the ice is liquid, once all the solid becomes a liquid, all the ice becomes water, then the water will ultimately warm up, right? If your house is warm, some people, I don't have the heat on in my house yet. I like it when it's a little chilly. But your house, maybe you're a family that's cold and you always keep the heat on. You want to stay warm. You wish you lived in Florida. Could be. The water's going to get hotter in your house than it's going to get in my house, because it's only going to reach the temperature of the room, and then it's not going to be able to get hotter by itself. But it's going to warm up. Once all of this ice is turned to water, you have to make believe time is going on now. I don't know how to make this happen, and I don't want you to have to watch a 30-minute video. Put the frying pan or the pot on the stove. Be careful. Pull your hair back. Make sure you're paying attention. And turn on your stove. Either turn on the fire or turn on the electricity to make the stove hot. And the metal is going to be touching the fire or touching the hot element of the stove, and the heat's going to transfer through this pot and into that water, and it's going to make the water that's all sticky and touch, it's going to start to make it move faster and faster, because the heat's going in and the particles are getting more kinetic energy, and they're starting to do crazy. And at some point, don't watch it because it takes forever if you watch. A watch pot never boils. Oh, it's going crazy, it's going crazy. All of a sudden, there's so much energy they can't hold together. And the stickiness they have, their attraction, is not strong enough for the kinetic energy. And all of a sudden, pow, they blow apart. And they turn into steam. They turn into H2O gas. Steam. We started out with solid H2O. We saw it turn into liquid H2O. And now we got gas H2O. H2O, H2O, H2O. It's water, 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 or the way you understand it. Let me try it again. Water, water, water. Water, water, water. 3 different phases. The only difference is the phase. This was not chemistry. This was a physical, 2 physical changes. Solid to liquid, and then liquid to gas. Now, if the pot's boiling yet, or if it's still boiling, if you want to be careful, if you see the steam coming out of the pot, Put your hand over it for a couple of seconds, just till you see some steam touch, and then go like this and feel it. Feels a little damp because your hand is not that hot. You put your hand on top of the steam comes up really hot, it touches you, and then it condenses back into a liquid. So if you could do that, you can go from solid to liquid, liquid to gas, gas back to liquid. Put your arm in the freezer, see how long it takes. You can make your hand an ice cube, and we can go back and forth through all these phase changes. You have to know all the names of the phase changes for water. There's 6 of them. They were in the notes. Make sure you don't forget them. All right. This was the first, but really it's the last for me. I already did the others. Watch all of these little recordings, get all the data, and then we're going to start working on this lab report. Now, I know something that you don't know. This is going to be a really, really hard lab report for you to write because you don't know any chemistry. Don't worry about that. That's my job. I know you don't know any chemistry. I haven't really taught you too much chemistry yet. We did some measuring, we did some of this, we did some of that. I'm going to teach you some chemistry. This lab is about having fun in the lab. Now, I know you're not in the lab this year because you're all kind of stuck at home and you're only coming to school once in a while. It's all a video lab. There'll be other days we'll be doing lab. Hopefully in the spring we'll be doing lab. And if not, in college or next year, you come back and visit. I'll do chem lab with you for fun. No lab reports next year. These experiments are all way over your head. You can't possibly know what all these formulas and names are. How are you going to know any of this stuff? Do not let it bother you. I'm going to give you all of the answers, okay? All of them. I want you to write stuff out. I want you to write names and formulas so you start to make the connection between H2OG, which means H2O gas, compared to H2OS, which is solid. I want you to write the formula Li2CO3 for lithium carbonate. Now, how would you know that? You don't know nothing, and that's okay. It's okay. I know you don't know it. But when you start to write these formulas, you might say to yourself, wait. Lithium carbonate, Li is lithium. It's element number 3. Look it up. C stands for chocolate chip cookie, which I love. It also stands for Charlie. It also stands for carbon. Write these things. Li2CO3S. That's a solid. How cool is that? You're going to start to write some chemistry. You're going to write balanced equations. You don't know how to do that either. Who cares? Write down the answers, all in that packet I gave you. I want you to write because I want you to begin to feel, what is it like to write formulas? What does that arrow mean? You'll get used to it. What are all these AQ for aqueous? What the heck is aqueous? You'll remember. It means dissolved in water. What is S or L or G? Solid, liquid, gas. I want you to get familiar with this stuff. Have some fun and do not worry. You don't know any chemistry. You don't have to know it yet. You're going to have to copy it. I'm going to give you the answer. I give you the answers. Just copy it. It's going to be an easy lab report. You're all going to get a 25 out of 25. But the important thing is you're going to learn some chemistry. You're going to learn what symbols mean. You're going to learn capital letters matter and lowercase letters for the second. It's not capital L, capital I. That stands for Long Island, and they talk funny on Long Island. Not like me, not like you. Okay, keep going. Watch the rest of these videos or recordings. I call them videos because I'm old. They used to put this stuff on tape. Now I don't even know how it works. It's all magic. It's Zoom. Zoom, Zoom, Zoom. Okay. I'm having a great time.